The question itself here seems quite straightforward. We're just looking for the value of t, and they didn't provide any free info. So I don't know whether t is an integer or not, whether it's positive or not. I don't know anything about t. Looking at the statements, I'm tempted to start with statement 2 because it's only talking about t, whereas statement 1 seems more complicated. It has another unknown there. So starting with statement 2, if I know that t cubed is 216, would I be able to find the value of t? I don't actually need to know how to do it. I just need to be confident that someone could do it and that it can only lead to one possible value of t. Now, if we were dealing with an even exponent here, this would not be sufficient on its own, because when we take the even root of an unknown, we can't tell which side of 0 the whole thing started. But in this case, we have an odd exponent, so if the end result is positive, which it is, it's 216, then the starting point must have also been positive. After all, if you start with a negative starting point and then multiply it times itself an odd number of times, you're going to end up to the left of 0. So if we ended up to the right of 0 at positive 216, we must have also started to the right of 0. So this statement is sufficient on its own. If you're curious, the cube root of 216 is 6, but we don't actually need to know that in order to feel confident that this statement is sufficient on its own. So let's take a closer look at statement 1 right after the intro. So with statement 1, what's really bothering me here is that I have a new unknown that wasn't in the question stem. We're not just talking about t here, we're talking about t and s. If only there was a way for me to somehow make the s disappear. Well, hang on, maybe if I subtract s from both sides, would that work? Oh yeah, I think that would just leave me with t equals 6, which is a singular value for t. So this one is sufficient on its own as well. And what's interesting about this question is that when you really evaluate the two statements, you realize that they're giving you the exact same information. Statement 1 essentially tells us that t equals 6, and statement 2 essentially tells us that t equals 6. So as I mentioned in section 2 of my book, which you can read for free on quantreasoning.com, this is a situation where you could eliminate answer choices A, B, and C without even reading the question. Because these two statements are inferentially equivalent. They're giving us essentially the same exact information. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.